part of the review for the practice final and the final. Both exams cover the same material. I think you get the most out of this if you do the review yourself first and then watch this video to see if you got the answers right. Working through them on your own gives you the best practice for the actual exam. Now I'm going to start with truth tables here, and keep in mind that X and Y stand for Boolean expressions. So what we're looking at here is all we really care about is whether the expression is true or false. And these combinations of values in the first two columns tell us basically all the combinations possible of true and false. Now I've got the first couple of columns filled in, but let's go over them. For not X, we just reverse the values for X. So true, true, false, false becomes false, false, true, true. Second column, we're combining not X and Y using the OR. Well, remember with the OR, if either one is true, we get a true. If they're both false, that's when we get a false. So first row, we have a false and a true. We get a true. Two falses is a false. Two trues is a true. And true and false is a true. Okay, final column, X and this expression. Well, we'll use the column for X and this column and apply the rule that if both of them are true, we get a true. Otherwise, it's false. That's the rule for and. Okay, so let's do that. So we're going to get a true. This one is true and false, so we get a false. And then we have the two false X's, so those are also false. And that's our final answer. Okay, next example. We're going to start by doing not X, so just reverse the X again. False, false, true, true. And then we're going to do not Y, so reverse the Y's. And that'll be false, true, false, true. And now we want not X or not Y. And remember how we do that. Two falses is a false, otherwise it's true. So in the first row, we do have two falses. That's a false. And then we're going to get true, true, and true. Okay, next column, X and Y. Well, here's X and Y, and our rule is if they're both true, we get a true, which is true in the first row, otherwise false, and at least one of them is false in the remaining rows. And finally, we have not of this expression we just figured out. So not of the expression X and Y, and that means reversing this truth table. So we're going to get false, true, true, true. Now the interesting part is that this truth table for not X and Y is exactly the same as the one for not X or not Y, and that means that those two expressions are logically equivalent. So if we're doing something like a database query and one form is more efficient or convenient than the other, we could substitute. Okay, in the next example, we have an expression that involves three different variables. Well, with three variables, in order to get all the combinations, we need 8 rows instead of 4. So, and it doubles every time you add a variable, just like with bits. The number of combinations doubles whenever you add a bit. So you can see here I'm doing the X's all true and then all false, Y's true, true, false, false, and so on, and Z's alternate every row. And if you think of any possible combination, you'll find it in here. Okay, so our first part of the expression is not X. So let's do false, 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 and then true, 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 true. Okay, now we have Y and Z. True, and they're both true, as it is in the first row. This next row, false, and 2 more falses. And then we have another true, because here both Y and Z are true, and then the rest false. Okay, now we want the OR of these two expressions, not X, and the expression Y and Z. So using the rule for OR, if at least one is true, the whole expression is true. So I'll have true, and then false, 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 because they're both false, then a true, and for the rest of them, we're going to get true. Okay. Now, so that completes that. Now let's look at the format for the exam. So the question might look like this. Suppose x and y are both true. What is the value of the expression x and not x or y? So we actually did that expression first. And you could do the truth table and copy, or you could do what we do in the truth table, which is work from the inside out. So in other words, we get each individual piece of the expression, and then we combine them. So if you look here, okay, we have x, and then we have this other expression. The other expression has two parts, so we start with not x. X is true, so not x is false. But y is true, so this part is true. X is also true, so the and of both of them is true. And that's the same thing as we got in the truth table in the top row where x and y are both true. So you can work it out that way as well. And so this one is true. And with the second question, x, y, and z are all false. So I could say, all right, if x, y, and z are all false, y and z is false. On the other hand, not x is true. I have a true or a false, and that gives me a true. Or I could have done it in the truth table and read off from the line where they're all false that I'm going to get the value true. Okay. Consider the following if statement. And we have some questions about that. So let's have a look. Here I have this variable multval, and I want to know the value of multval at the end of this if statement if x equals 4. So, okay, if x equals 4, 4 is less than or equal to 5. So multval will be 25, and I don't even look at the rest. All right, 25 is answer A, so I'll put that here. Okay, what if x equals 7? Well, it's not less than or equal to 5, but it is bigger than 6. So I'll get the answer 15, which is B. Okay, what if x is 12? Well, it's not less than or equal to 5, but it is bigger than 6. First one that's true, the answer is 15, and that is, again, B. Okay, now it's also true that it's bigger than 10, but remember the way these work. You go until you find a true condition, you take that answer, and you're done. You don't look at any more. Okay, now what if x equals 6? Well, in that case, it's not less than or equal to 5, it's not bigger than 6, and it's not bigger than 10. So the value of x won't get changed in this expression. So multval will have its original value, which was 0, and that's answer D. Okay, now let's do another one very much like it. So here we have another if statement, and we want to know the value of multval at the end of this if statement if x equals 21. Well, 21 is bigger than 20, so we take the first option, which is 9. That's answer B. What if it's 16? Well, it's not bigger than 20, it's not less than 15, and it's not less than 12. So none of these apply. That means it keeps its original value of 10, which is answer A. What if x equals 13? Well, that's not bigger than 20, but it is less than 15, so the answer will be 8, which is C. And finally, if x equals 11, not bigger than 20, it is less than 15, that's the first one that's true, so we get 8 again, which is answer C. Now, it's true that x is also less than 12, but we never go there because we already found one that works. Okay, here's another if statement. So x equals 5, and we want to know what prints in the list box when this code is executed. So is x less than or equal to 3? No, so we ignore that one. Is x bigger than 3? Yes, so we're going to print greater. Now, what about this? Yes, x is greater than 3, but it's also equal to 5. So do we get both of these? Do we get equal? No. The point of this question is you will only get the first option where the condition is true, which would be greater. So the answer here is C. Okay, that completes part 1. We'll do part 2 in the next video.